I realize these area optimization problems are a little bit difficult, and so I made this video which is going to show you 4 area optimization problems, so that after you see a few, you might think maybe they're not so hard, and you might also think that maybe they're all kind of the same. So let's go through these and let's see if your understanding improves. First thing you do when you're doing an area optimization problem is you write an equation for the quantity you're trying to maximize, which is the area. And pretty much the only area formula we're going to use is area equals length times width. Okay? Now what's the problem with the formula area equals length times width? Well, you know how in your calculator when you write a formula here and you got an output which is y and you got an input which is an x? You notice that there's only one input x, right? So the problem with a equals LW is there's 2 variables as the input, length and width. So we need to make that into an equation that only has one input. And that's the only hard part of this. And so how do we do that? We do that by relating L to W, because all these area optimization problems, the trick to them is that length and width are related. They're not independent. Once you choose one, the other one is already chosen for you. So there really is only one variable. It's kind of like our chi-square problems where, you know, the degrees of freedom is not like, you can't vary like every single number in the table. You can only vary some of the numbers in the table. After you vary those numbers, then the others are all calculated for you. So it's the same thing. Once you pick length, your width is already determined. So it's not like you have 2 variables, so let's eliminate one of them. Okay? Alright, once you find area equals length times width and you've eliminated either the length or the width, then you can use the calculator to, put the a in as y, and you put the length of the width in as x, and you make a formula here, and then you graph it, and then you'll see a nice parabola. And you say, hey, the maximum's right here. And once you find that, you're going to have an xy coordinate for the maximum point, and then you can interpret that point in your answer. Okay, so now that we have that introduction, let's begin. Okay, so this is like the most basic kind. You got 128 meters of fence, and you're going to try to make the largest possible rectangular area you can make. Okay, so let's draw a picture first. That helps. So you got 128 meters, okay, and you have a length and you have a width, and let's just label them all. Makes it easier, okay? So first we're going to say, what is our equation that we're trying to optimize? And that is the area equals length times width. Surprise, surprise. Okay? Now what can we say about length and width? We need to relate these two so that we don't have area equals length blah 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 width blah blah blah. We want to have area equals length blah 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 only with no width, or vice versa. Okay? So, and usually in IB problems they're going to walk you through this. You don't have to like follow all these steps. You don't have to memorize them because the IB wants you to do step 1 first, and then they ask you to do step 2, and then they ask you to do step 3, and before you know it, you're on step 4 and you're done. Okay? So it's not so bad. Alright, how do we relate length and width in this case? By the fact that we have 128 meters of fencing only. So we could say length, the 2 lengths plus the 2 widths added together gives you 128, right? Okay? Now, let's say that we want to eliminate W. Okay, so let's try to find an expression with W on the left and the L's on the right. So we'll say W plus W equals 128 minus L minus L. We could be good at algebra and we'll say, hey, that's equal to 128 minus 2L. And we could also say that W plus W is also 2L. Okay, so now we have an expression which relates L and W. Oops. This was W, right? To W. Okay. The only thing is that we have a 1W here. We don't have 2W. So how do we make this into 1W? We divided both sides by 2, and we have W equals 128 divided by 2 minus L, right? 128 divided by 2, by the way, is 64. So we have W equals 64 minus L. right? So let's put that here, and all of a sudden we've eliminated W. And now it becomes very easy. Now, in the calculator, A is also known as Y, and in the calculator, L is known as X. So we can rewrite this as like that, and then we can put it in the calculator. Let's see, go to Y equals, and in Y equals, we're going to put X times 64 minus X. 64 minus X. And then I'm going to graph it. And I don't see it because it's it's off the screen. Now, when you do graphing, first thing you always want to do is zoom fit, because maybe it's just like right above there. Zoom fit's going to bring in it's going to make the Y axis, the Y maximum as high as it needs to go. It makes the Y minimum as low as it needs to go, and it's going to find it for you. It's not going to adjust the X's though. So first thing we want to do is zoom fit. There we go. There we see the parabola. Do we have the maximum of the parabola? No, we don't. Look at that. It's like over here. So how do we grab that? Well, we need to make the X maximum a little bit bigger so that it grabs that. So let's make the X maximum equal like 100. Okay. Now let's graph it. That's better. That's better. There's the maximum right there. Ooh, but it's cut off. How do we get that back? Zoom fit. Zoom fit. Alright, perfect. Now we see the maximum. And we can find the maximum easily by doing second calc. And you can see it's a lot harder to zoom than it is to find the maximum. You say, oh, left, there's the vertex right there. We're going to put the cursor a little bit to the left there, left bound, yeah, that's fine. And then we use the cursor right arrow, and we go a little bit to the right of the vertex, and we say right bound, yeah. And that says, is that your guess? Yeah, sure, any guess is fine, because there's only one maximum. There it is, it's 32, 1024. 32, 1024. Guess which one's the area? It's the Y. Guess which one is the length? It's 32. Okay, remember we related the length to X and we related the area to Y. So now that we have the 32 length and area is 1024, let's figure out what the width is. Now we can use this convenient equation here to figure out what the width is. It's 32. Also, wow, it wasn't a rectangle at all. It was a square. Well, I guess a square is like a type of rectangle, but okay. Alright, so that is the most basic kind. I'm sure you'll see one of those in the future. Second type. Okay, this is a little bit more complicated. How do they make it more complicated? Well, what do? They put a river next to the area you're going to fence. If you got the river, you don't need to fence the whole thing. So they're only going to fence this rectangular area like that, and then they don't need to fence the fourth side. Okay? First thing you need to, okay, and let me read the problem. A farmer has 2,400 feet of fencing and wants to fence off a rectangle field that borders a straight river. Find the dimensions of the fence to maximize the area enclosed by the fence. Okay, the only difference is now one of the walls is a river. Okay, what about the area equation? Does it change? Area equals length times width? No, it's still true. Area still is area length times width. Okay, now the river doesn't count as a wall, so that affects our step 2. In step 2, we want an equation that relates length and width. And what is that going to be? Well, we know that there's 2,400 feet of fencing total. Okay, so we're going to say W plus L plus L. Whoops, not plus L, because we don't have a fence next to the river. So we actually only have W plus L equals 2,400. Okay? And then we're going to say, let's try to get rid of W. To get rid of W, we are going to put all the W's on the left and all the L's on the right. So we're going to have 2W equals 2,400, and we're going to subtract L from both sides, so it's going to be 2,400 minus L. Okay, and then we want W all by itself, so we need to divide both sides by 2, and then we get W equals 1,200 minus L over 2. And then we can put that in here, and we have eliminated the W. or we've eliminated the W. We got that now. Okay? So we have area equals length times 1200 minus length divided by 2. Now how do we optimize that? How do we find when the area is maximum? Now that we have one input and one output, we can change all the A's to Y's, and we can change all the L's to X's. Okay? So it's going to look kind of like this. Okay? Let's type that in the calculator. Y equals, and we're going to clear this out, and we're going to put X times 1200 minus, and then let's put this in the parentheses so that we don't screw it up. Like that. Okay, let's graph it. And remember, if you don't see it very well, first thing you want to do is zoom fit. Zoom fit. That's better. That looks more like, oh, we don't have the important part of the parabola. The important part of the parabola is over here, the maximum. So let's move over a little bit. We need to go a little bit farther to the right. We do that using window and X max. Instead of 100, we'll put like 1,000. That should be enough, right? Oh my God. Too high. Now let's use zoom fit again. You need to kind of alternate. First you adjust the X, then you adjust the zoom fit, and then you adjust the X. Man, it's still to the right, and we put 1,000 in there. Now it's got to be more than 1,000. Window, let's change that to 2,000. That'll do it. Yeah, now the only problem is we need to do zoom fit again. Zoom fit. Alright, now we did it. Okay, now let's find this vertex here. How do we do that? Second calc maximum. And let's see, left bound. We go a little bit to the left of the maximum. Enter. We go a little bit to the right of the maximum. Enter. What's your guess? That's fine. It's 1,200, comma, wow, 720,000. Wow. So it's 1,200, comma, 720,000. So this is your X, this is your Y, this is your area, and this is your length. Right? Yeah. There we go. Okay, so what's our width? We can find our width using this equation. We can put 1,200 minus, the length is 1,200 divided by 2. And what do you know? It's 1,200 divided by, the remainder is 600. So this is 600 and this is 1,200. So instead of being a square, now it's like kind of a 2 by 1 rectangle. Interesting. Okay? Alright, and if they ask you for the area, there it is. Third one. Okay, the Riding Stables has just received an unexpected rush of registrations for the next horse show and quickly needs to create some additional paddock space. A paddock is like a horse fenced-in area. There is sufficient funding to rent 1,200 feet of temporary chain-link fencing. The plan is to form 2 paddocks with 1 shared fence running down the middle. What is the maximum area that the stables can obtain, and what are the dimensions of each of the 2 paddocks? Okay, so that means that it's going to look kind of like this. Okay, we don't know if it's a square, if it's a rectangle, or what, but it kind of looks like that. And we have 1,200 feet of fence available. And the area is going to be maximized. Well, what do you think the area is going to be? What's the formula for area? Hey, there it is again. Length times width. There it is again. Okay, how do we eliminate width? We are going to make an equation which relates width to length. How do we do that? Well, by the fact that we have 1,200 feet of fence available. So we could say, oh, this is like length, right? This is length. This is length. This is W. This is W. This is W. Let's see, we're going to add all these up. So 3W plus 2 length equals 1,200. Does that make sense? Right? 3W's, 2 length equals 1,200. Okay, now let's, we're going to try to get rid of W, so let's solve for W. We're going to subtract 2L from both sides. We're going to put all the W's on the left side, all the L's on the right side. We get 1200 minus 2L equals 3W. Now we can get rid of the 3 by dividing both sides by 3, and that means W equals 400 minus 2/3 L. And now we're going to put the W into there. And now we're going to have area equals length times, and then it's 400 minus 2/3 L. Okay, and now that we have only one input, which is L, and we have one output, which is A, now we can convert that into Y's and X's, and we can put it in our calculator. Okay, so let's do that. Y equals, and we'll delete what's in there, and then we'll put X times 400 minus 2/3. Oops, let me put a parentheses around that. 2/3 times X, close parentheses, graph. Hey, we made the screen so big we can see it without doing zoom fit. Okay, now we need to find the maximum point. How do we do that? Stat calc. Oh, not stat calc, second calc. And you go down to maximum. Sometimes you try to find the minimum, so. I can't, oh, there it is. Do you see where the cursor is? There it is, a little bit to the left. I guess there is a disadvantage to having it just in the corner here. It's covered up by the letters. There's your guess. Oh, there it is. So it's X equals 300, Y equals 60,000. 360,000. Okay? So X equals 300, Y equals 60,000. And what if we want to know the dimensions of the paddock? We already know the area of the paddock. It's 60,000. The dimensions of the paddock, we know that the length is 300. What is the width? Hey, we can use this equation here. So it's 400 minus 2/3 times 300. 400 minus, and then this cancels with that, so it's 200 equals 200. Okay, so each W is 200. Each length is 300. Alright? Alright. Last one. This is similar to the one that's in our problem set. Okay? This time you have fencing, okay, that you have 40 feet of fencing available. And in this case, you have like a head start. You have a wall built that's 20 feet long, and basically what you want to do is you want to figure out how to arrange this. Like, what's the length and width of the total area here? This is going to be actually this is 40 feet of fence is like too small, so it's just going to end up being like the river problem. Okay, so let's change this problem. Sorry about this. So instead of 40 feet, I'm going to put 100 feet. Okay, we have 100 feet of fence. All right. Now it'll be a different problem than the river problem. Okay. All right. So what are we going to have? We're going to say area equals length times width. What a surprise! Area is equal to length times width. We didn't know that, did we? Okay, area equals length times width. Now we need to find an equation which relates length and width. How do we do that? We use the fact that we have 100 feet of fence available. So, let's see. Now this one's the most complicated that we've had so far. We know that this is W. We know that this is W. We know that this is L. But what's this? This isn't L. It's actually smaller than L, right? It looks like it's L minus 20. Does that make sense? Like this is L, would be L minus 20 feet. Okay? So let's write that in the equation. We're going to have W plus L minus 20 equals 100. Right? Okay. And then we can combine the W's into 2W. We can combine the L's into 2L. And then we can add 20 to both sides. And then we'll get 120 here. Okay. And then we want to get rid of the W. Let's just, to vary things, let's get rid of the L this time. So we're going to solve for L. So instead of solving for W, because I just want to show that you can do either way, it doesn't matter. So subtract 2W here, subtract 2W here. We end up with 2L equals 120 minus 2W. Then, if you divide both sides by 2, you're going to end up with L equals 60 minus W. Then you put that into the L here, and you're going to have A equals 60 minus W times W. So now you have one input, which is W, and you have one output, which is A, so you can replace that with Y's and X's. 60 minus X times X. Now we can put that in our Y equals. We're going to clear what's in there, and we're going to put 60 minus X, 60 minus X times X. And I'm going to graph that. Oh, it's too small. Let's do zoom fit. It's always the first thing we try. Actually, sometimes the first thing you do is zoom standard, but that's only when you have like a very well-behaved problem that's small. Oh, look at that. The max might be off to the left. So let's do this. We're going to go a little bit more to the left using window. We're going to change X-min to like negative 500. I think that'll do it. And afterwards, for sure, we're going to have to do another zoom fit. There we go. There's the maximum, but we do need to do another zoom fit. Zoom, so that we can get all the way to the top. Okay, there it is, somewhere there. Okay, so let's now figure out what the maximum is. We figure out the maximum by doing second calc maximum left, right, guess. There it is. X equals 30, Y equals 900. 30, 900. So in this case, the X is the width, right? So our width is 30. What's our length? 60 minus 30 equals 30. So the length is 30. The width is also 30. In this case, it came out to be a square, didn't it? Okay, and then the length minus 20 is 10. Alright? 30, 30, 30, 10. Alright. And the area, of course, is 900. So, after we did 4 problems, don't you think we see some kind of similarity between them? Like, for example, we always start with A equals length times width. Right? That never changes. The other thing we always do is we make a formula or an equation like this, which adds up the widths and the lengths of the fences that we have, and it totals up to the total that they give us. Okay? After we find an expression which relates length to the length and width, we put it into the original one, and then that makes it possible to have an equation with one output and one input variable. We change that to y and x, we put it in our calculator, we find the vertex, or the maximum point, and then we take the value we get for the width or the length and we plug it back into that equation and we get the opposite one. If we got the length, we find the width. If we got the width, we find the length. So that's pretty much it. Hope you are feeling more comfortable with this.